Good day, grade 10 learners. Welcome to math class by teacher Olivia Jane G. Tatunay. For today's lesson, we're going to find the probability of two events or the symbol probability of A union B. Please be guided with following reminders. Always mute your microphone if not being called. Focus on the lesson. Make notes for your today's learnings. Stay in a quiet place. And have math fun while solving. Now, let's review using the following guided question. First question, which symbol represents the orange portion? A, B, or C? Very good. The correct answer is letter B. The orange portion represents union. What do we mean by union? So, union contains all elements that are present in both set A and set B. Next question, which symbol represents this purple portion? A, B, or C? Very good. The correct answer is letter A. The purple portion represents intersection. What do we mean by intersection? Intersection contains elements that are present in both set A and set B. Meaning to say these are the elements that are common in both sets. Number 3. Which symbol represents the set of event? A, B, or C? Very good. The correct answer is letter C. We are using the braces to represent set of notation. Here are the example of set. For set A, we have an infinite set. For set B, we have a finite set. And for set C, we have infinite set also. Infinite set means never ends, while finite set has a common endpoints. Now, to start our lesson, let's do activity 1. Identify if the following set C is an intersection or union of set A or B. Number 1. Set A contains 1, 3, 5, B with an element 0, 2, 4, and C with an element 0, 1, 2, 3, 4. Very good. The answer is union. Set C contains all the elements that are present in both set A and set B. Next question, number 2. With set A contains negative 1, 0, 1, set B contains negative 2, 0, 2, and set C contains 0. Very good. The answer is intersection. So 0 is the common element in both set A and set B. So 0 is the intersection of the given two sets. Next question, number 3. Set A contains the elements T, W, O, B contains T, I, M, E, and set C contains element T. Okay, very good. The answer is intersection. So T is the intersection of set A and set B. it is only the common element present in both sets. Number 4, set A with an elements MINE, set B with an elements NINE, and C with elements INE. Okay, very good. The answer is intersection. So, set C contains all elements that are common in both set A and set B, which are INE. Last item, set A contains TADEK, set B contains SULIBAO, and set C contains TADEK, SULIBO. Very good. The answer is Yunyo. Set C contains all the elements that are present in both set A and set B. Great job, grade 10 learners. Now we are now ready to find the probability of two events or in symbol, probability of A union B. So, using the formula stated, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. In this situation, we're going to consider the following. To find probability of A, find probability of B, and of course, find probability of A intersection B. Now, how do we get these three? Let's study the following example. Number 1 illustration we have here, given a Venn diagram. We can see here that set A contains 13 and 5 and set B contains 10 and 5. And 5 is the common element of set A and set B, meaning to say 5 is the intersection of the given two sets. So, first thing to do is to list the elements containing both set A and set B. So, we're going to list. Then, after that, we're going to add the elements that belong to set A. So, 13 plus 5, that is 18. Likewise, for set B, we're going to list the elements which are 10 and 5. And after that, we're going to get the sum. So 10 plus 5, that is equivalent to 15. Very good. Now, how are we going to find the probability of the following? So take note, when we are getting the probability of an event, to get the probability of an event, we need to add all the elements present in the given set. So we're going to add set A and set B, which lead us to 33. Now, to get the probability of the event, we're going to use the formula P of E is equal to sample over population. Sample means possible outcomes, and population means the total number of elements or quantities given in a set of data. Hence, we can say therefore, the probability of A is equal to 18 over 33, meaning to say there are 18 elements present in set A out of 33. For number 2, probability of B is equal to 15 over 33. Meaning to say, we have 15 elements that is present to set B over 33. And for the intersection of probability of intersection of A and B, so by substitution, we have 5 over 33. So 5 is the common element that is present in both sets. Now, we are now ready for using the formula. So, given the computed value, no file back. So, we're going to use the formula and we're going to substitute the computed value. So instead of writing probability of A, we're going to write 18 over 33. Instead of writing probability of B, we're going to write 15 over 33. As well as, instead of writing probability of A intersection B, we're going to write 5 over 33. Now, to simplify the equation, we're going to use the PEMDAS. So we're going to add first before we subtract. So adding similar fraction, we're going to add the numerator, then copy the denominator. So 18 plus 15, that is equal to 33, then over 33 less 5 over 33. So the probability of A union B in here is equal to 28 over 33. Next situation we have here. So what are the elements that is present to set A? So we have here 25 and 3, set B. We have 18 and 3, and observe that there is an element outside the two sets. So how does this affect this situation? So we can write the given here. A intersection B is equal to 3, since this is the common element in both sets. We're going to list elements in set A, which is 25 and 3. So like what we did a while back, we're going to add the elements. So 25 plus 3, the sum is okay, very good, that is 28. For set B, we're going to list also. So we have here 18 and 3. So what is the sum? So what is the sum of 18 and 3? So 18 plus 3, that is equivalent to very good, that is 21. Now, to get the universal set or all elements that is present in this situation, we're going to include 6 since it is part of the given set of data. So to get the population, we're going to add 28, which is from set A, 21 from set B, and 6, which is the outside of the two sets. So the sum of the given elements is very good, that is 55. Now, using the probability of an event is equivalent to sample over population. So we're going to get now the first one, probability of A. So we're going to substitute the sample or the number of outcomes, which is 28, then over the population, which is 55. Meaning to say in here, we have 28 elements over 55 for probability of A. Next, for probability of B, so by substitution we have 21 over 55. It means that we have 21 elements present in set B out of 55. And of course, for the intersection of A and B, so if we're going to get the probability, so this will be equal to 3 over 55. So 3 here is the common element over the population, which is 55. Now, since we have now ready for the 3, so we're going now to substitute in the given formula. So instead of writing probability of A, we're going to write 28 over 55. Instead of writing probability of B, we're going to write 21 over 55. And of course, instead of writing probability of A intersection B, we're going to write 3 over 55. Now, using PEMDAS, we're going to simplify again the following equation. So 28 plus 21, that is 49 over 55, plus 3 over 55. So addition and subtraction of similar fraction have the same rules. So we're going to subtract or add the numerator, then copy the denominator. Therefore, in this given situation, probability of A union B is equal to 46 over 55. Now, let's consider a real-life situation. For number 3, this is the problem. At Barangay Barikir with 300 households, 210 has television, 65 has radio, and 20 own both television and radio. Find the probability of the union of television or radio. So let A be the television and let B be the radio. So given already the number of household which has the following. So set A here is equal to 210, set B is equal to 65, and for the Q or the population, we have 300 household, and of course the intersection of A and B is equal to 20 since they own both television and radio. So let's see the illustration. So you observe in this Venn diagram, when we add elements belongs to the elements that are belong to set A, we have 190 plus 20, so the sum is 210. Likewise, in set B, when we add it, 20 plus 45, that is 65. So that's how to illustrate a given problem, word problem. Now, since it's already given, the sum of the given sets, so we can say that probability of A is equal to 210 over 300, as well as probability of B is equal to 65 over 300. Then probability of A intersection B, that is equal to 20 over 300. Now using the formula, we're going to get now the probability of union of television or radio. So by substitution, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So instead of writing this, we're going to write the equivalent value. So probability of A, 210 over 300. Probability of B, 65 over 300 minus 20 over 300. So using PEMDAS again, we have 210 plus 65. That is equal to 275 over 300 minus 20 over 300. So therefore, we can say that the probability of union of television or radio in this given situation is equal to, very good, the difference which is 245 over 300. But since this is can be simplified in lowest term, so we're going to simplify. The common factor on both numerator and denominator is equal to 5. So the final answer will be the probability of A union B is equal to 49 over 60. Now, let's move on to another situation. In a family of 5 members, the wife and household does the following at home: laundry, cooking, and cleaning, while the 3 siblings does the following: laundry, cleaning, and fixing beddings. Find the probability of union of parent or sibling chores. So with set A, be the laundry, cooking, and cleaning, we have 3. So set B, we have laundry, cleaning, and fixing bedding, so there are 3 also. And for A intersection B, we have cleaning and laundry. So if we're going to list the elements, we have set A will be equivalent to 3, set B will be equivalent to 3 also. For the universal, we're going to add set A and set B, which is equivalent to 6. And of course, the intersection of A and B, that is 2. Hence, we can say the probability of A is equal to 3 over 6, probability of B 3 over 6, and probability of A intersection B is equal also to 2 over 6. So by substitution, we now here, so 3 over 6 plus 3 over 6 minus 2 over 6. So that is equivalent to 6 over 6 minus 2 over 6, which leads us to difference 4 over 6, or in lowest term we have 2/3. Now, other situation where we can use or apply probability of union of 2 events in real-life situation. Example, favorite snack and drinks, Facebook and Instagram accounts, outfits of boys and girls, habits of young and older generation, correct answer of 2 students, and many more. For generalization, for every union, when we say union, it belongs to A or B. Take note of the word or. When we say union, we are comparing 2 sets. And when we say intersection, it must belong to both A and B. It contains an element which is common to both set in the given situation. Now for your assignment, so kindly screenshot this. Although there will be given activity sheet in your envelope or in your face-to-face class. And of course, for number 2, the problem solving. So when we say printed and digital is the soft copy of your modules, while the printed is the one you are receiving. And of course, for your additional activity, you will go and answer the post-assessment in your module 3 and if possible, show your solutions. Okay, so that ends my lesson for today. Hope you learned something and have a wonderful math time. So this is teacher Olivia Jinji Tatuna, your mathematics teacher, saying thank you for listening. Hope you have a math fun time. Until next time.